And then, okay, yeah, so you can log out and log in, and then the audio should be better. The other thing I need to do is I need to open my Jupyter notebook. So not this one. And I need to share my screen with you. Okay, don't forget. Okay, so I'll open my Jupyter notebook just now. Not this one. Okay. So I'll just open a new one. Oh, sorry. Let me share my screen so everybody sees how I'm doing. Yes, you can download the videos both on Zoom and on YouTube. Oh, I think you can download the videos. Please, can someone confirm that you can download the videos? I sent you links, so you should be able to download them both on Zoom and on YouTube. Okay, great. So I think people can download. People can download the videos. Share myself. Okay. So I opened Jupyter and then I go to new. This Python 3. So I'll tell you something about this Python 3. There's a way you can, so the files we are working on now, somebody has to have Jupyter to be able to open it and then execute it. Yes, you don't have to execute it one by one. I think you can just go to kernel, restart and run all, and it will just run all the commands that we did yesterday. Okay, so you can do that. The interesting thing will be, oh, there's the 5. Thank you. The interesting thing will be if you need to give the work you have done to somebody who doesn't have Jupyter Notebook. Okay, for many of the things I did in the past, I didn't have Jupyter Notebook. I will just type my Python code and then use Python to run it, and they are running. So what can you do if you want to give this to somebody who, okay, thank you. Yeah. To somebody who doesn't have Jupyter and wants to run your code. Okay. Because your codes, you can still run it even if you don't have Jupyter. So the person needs to can export it as a Python. So you can download as a, so if you go to download as, then you can download as, one of the options is Python. Let me change my font. If I go to file, I can download as, how did I do that? Yeah. Sorry. One of the options is download as Python, Python file. Let's try that again. Yeah, so you see you can download as python.py. Okay. So whatever you do, you can download it as a python.py file. So that py file, somebody can run it just using Python, Python 3 or Python, and then letting Python read that code. Okay, so not everybody has Jupyter Notebook. So I think we can. That's today. Does anybody have questions from yesterday? Okay, so you can go through an iterable list, and you can, yes, you can use for loops, or so for instance, so I can do for I in range 5. Okay, I put a colon, I put enter. The end, okay, it's very important. When you put enter, Jupyter is smart, it gives you 4 spaces here. So in Python, you don't use braces to show what part belongs to a loop or belongs to a section. The indentation shows it. So let's say I was writing this in Fortran, for instance. Okay, so this is pseudo Fortran code. I'll write this and I'll put an end. Okay, if you know Fortran, you know it. So you have to start and then you have to end the block in Fortran with end. So that's what you do in Fortran. Actually, Fortran, you don't do this. You do I equals 1, but similar. So Fortran, you will do something like this. Do I equals 1 and so on so. And then you end the do loop. So this end do loop shows you that you've ended the do loop and you can do whatever you want within the do loop. Similarly, if you're using C or C++, then you can do something like for I equals 1. So you initialize I less than 5, I plus plus. The way you know that this belongs to the same loop is, the same block of code is you use braces. So this is what you do in C, use braces, and you can say I plus equals 1. Okay, so you can do this in C. Okay. In Python, we make things very, so in this case, you see you have to put an opening braces and a final braces. Okay. In Python, we make things very easy for you. They make things very easy for us. So what you do is you just indent the code, and all the parts that is indented are the same as fall under the same block. So you don't use braces, you don't put for and n4. Okay, you just indent, and everything that is indented belongs to this block. So in this one, I can do print I. So that belongs to this block, and I can do j equals I plus 1. Unfortunately, this will not work. I have to first define my j here. Because if you just have j equals I plus 1, actually j equals I plus 1 will work. Yeah, actually j equals I plus 1 will work in this case. Because you are initializing j at the same time you're introducing it. Okay. Well, let's just put this, it doesn't matter. So this is going to run. Now, let's say I want to have another block under it, where I do for j equals, for j,
excuse me, j equals 0 or I equals 0?
J equals 0. I is not 0 because
in this equation it would be -1. I.
Here?
If j equals 0, I here would be 1, -1.
No, okay, no. Okay, don't worry. I'm just making this up. So I want I to go from. So for I in range 5 means I will go from
0 to 5.
Range 5 is a list that has 0, 1, 2, 3, 4. Starting from 0 up to but not including 5. So for I in range 5 is the same thing as saying for I in 0, 1, 2, 3, 4.
Mean I so equals j plus 1. I equals j plus 1.
I equals j plus 1. No, this is okay. Okay. In this case, I define a new variable. J. Okay. Is plus 1. Okay. So here I'm just defining a new variable. I don't have to put this one first. There's no problem. Okay, but I initialized it, but it doesn't matter.
حمص بكره تطبخوش فول وحمص ايش مالك بده شيء لازم نتعشى من طيب مش مشكله
Okay. So actually maybe I shouldn't. Okay, let's write something simple. So you can do something else. You can say print I start two. So the first one will print I, the second one will print I squared. And then what I want to do is I want to go from for j in range I. So this is another loop. And I want to print I, and I want to print, yeah, okay, I, and I want to print j. So this starts another loop. The loop is under the initial loop. And then this print I is in this block. It is not in, well, this is not directly in the first block. So you are going to see if you run this, it's going to run from I 0 to 4. And each time it will run from 0 to I. Okay. So here I put this. So let's do this. So I run this. So it prints exactly this. I'll send you the code and you can study the code more to see how these things work. So the main thing is that when you use Python, you use indentations, and indentation help you to know which part of the code belongs to which block. Okay. If you write this code, let's say you wrote this code like this. Let me rewrite this and I'll show you what I mean. Okay. So let's say I do this. Okay. This we know what it will give us. It will print I and then I squared. So let's run it. It will print I and then I squared. I and I squared. Okay. Because that's what we told the code to do. But let's take a situation where I don't indent one of them. So I don't indent this print I squared. I indent the first one. So the first one belongs to the for loop. The print I squared, I don't indent it. Who can predict what we're going to get in this case?
You have 0 to 4 and then 4 squared means.
Exactly. So you are going to, okay, so this is the first one we did and we ran this. So let me go to a new cell. So in this case, I don't indent this one. So you see only the print I is under the indentation. This print I squared is not under the indentation. So like you said, it's going to give you 0 to 4. It's going to print I. And then at the end, it will go to the next step of the program, and that is print I squared. This print I squared is not part of the loop. So it's not going to be printing for every I, the I squared. It's just at the end, after it has finished the loop. When it has finished the loop, the value of I will be 4. And then when it has finished the loop, then it will print, go to the next stage and print I squared. So let's run it and see. So I run this, so exactly. So you see 0, 1, 2, 3, 4 printed. Once it has finished the loop, the value of I is 4. Okay, and then it prints I squared, just like I told you to print I squared. So this print I squared was not in the loop, was not in the indentation, so it's not taken as part of the loop. Okay. In Python, there's no limit on the length of what you are writing. But the thing is, if it gets too long, you can use backslash to make a new line. So for instance, if this gets, let's say this first line was too long, I can use backslash and enter. And this is how I continue the line. So if I run it, so it runs just like before. So the line, okay, this line is not too long, but let's say the line is too long. Okay, let's make a long line. 1, 2, 3, 4, 5, 6, 7.
Excuse me.
Yes, 8, 9.
Yes, 10, when you print both in the loop, print I and print I square.
Yes.
I was expecting that I should have maybe 2 columns for I and for I square.
Oh,
But
no.
at least in 1 column.
Yeah, because the thing is, after each print, it prints a new line. I think, oh yeah, it prints a new line after each print. There's a way you can suppress the new line, and I think it works. I know how to do it in Python 2. I'll show you in Python 3. So after it prints a new line automatically. So you have to suppress the new line if you want it to print everything together. Okay. So I'll just show you that before we move to functions. So remember also we did while loop and try, and I'll give the example for try again, and then we'll move on to functions. Okay, so in this case, let's say you had to write 12, 13, 14, and it's too long. You can break it somewhere and put a backslash and enter. The backslash enter breaks it. Okay, and now you can run your file. You can run the code. So it's going to run. But because somebody asked me, so I'll put a comma here. So I think this is what you need to do. Sorry, that's my code. Yeah. So this is how you break a line. Okay, you put a backslash and hit enter. And it does that. I suppress the printing of end line by doing this. I think this is what I should do. No, it did not work. Okay, so I have to tell you that I don't know what to do. Let's say in what do you call this? Yes, let's say it was in Python 2. This is what you would do. Now in Python 3, I want to suppress the printing of the line. Yeah, in Python, let me try again. Maybe something happened. No. Does anybody know how to do this? If you want to suppress the printing of
Hello, Omar.
Yes.
You need to put them into the same print.
Yeah, I know, but yes, you can put them into the same print, but there's another way. If you don't want it to print the end of line,
Okay.
yeah, there's a way you can do it, and it will suppress the printing of the end of line.
Could you please repeat the question? I don't quite get it.
Okay, if I do this, print I, and then print I squared, it will print I, and then go to the next line, print I squared. Okay.
Yeah, the first print, maybe I comma I square.
Yes, you can do that, but there's another way where you can use to print, and the first print will not print a new line, and then you can print your new line later on. Okay, I'll find out and then I'll let you know. Sorry. In Python 2.7, it was quite easy. Okay, so sorry, I cheated. I looked online. So I think if you do this, and it was quotes, then this should, let's put a space. Okay. Then this should work. Let's see. Yeah, so this works. Don't worry about it if you don't get it. So what I do now is I print a space, and then instead of letting it go to a new line, I put this end equals quotes. So that suppresses the printing of the new line. So then when I do this print I squared, it will print on the same line. But then this print I squared, I did not suppress the end of line, and then it prints this. Okay, so this is just one of the tricks that you learn. Yeah, So you can use this end equals quotes to suppress the printing of an end of line, but okay. And then yesterday, one of the things we did was to use try and accept. So you can try something. There are many errors that you can get, and we just use one of the errors. And so this error is division by 0. So there's an error that is division by 0. So when you have a 0 division error, then that was the one we used yesterday. So I try to divide by 0, and then I'll print the answer. When it gets here, there's an error, and so it doesn't do the error. I mean, ordinarily it would have exited and told you there was an error, but if you use try and accept, then you can okay. So when you use try and accept, then you can try something, and if there's an error, you can do something else. Or another thing I can do is I can say answer is 12 over 0, and if that's okay, if I didn't know the value of the variable, let's put variable 1 and let's call it 0. So let's say I didn't know the anything about the variable. So if the variable is 0, I want it to give me answer is 12 times the variable. Okay, but if the variable is not 0, I want it to give me answer divided by. So what I want is I want 12 divided by
variable 1.
I want 12 divided by the variable. Okay, but if the variable is 0, I want it to give me 12. But okay, let's do it this way. Simple. If the variable, I forgot. Thank you. If the variable 1 is 0, I want it to give me 1000. But if it's not 0, I want it to give me the right answer. Okay, so I do this and I can run it. Thank you. So you see, let's actually put a print. So I run it now. Sorry, what happened?
Answer. There is an S.
Oh yeah, S. Thank you. Thank you. Yeah, I could have read it to know that there's a problem there. So let's run it. Okay. So when it can divide, I want it to divide and print the answer. If it cannot divide, I want it to print 1000 and tell me that there was an error in the division. So it does exactly that. If I change the variable 1 to 2.0, you'll see that it's going to just do the division. Okay, and it does the division and there's no error. So when there's an error, when you think there could be an error, for instance, sometimes some numbers come to you and you have to find the square root. Okay, thank you. And you have to find the square root. And you want to check also if it can find the square root or not. Because if it's the square root of a negative number and you are not using complex variables, then it's going to give you an error. So in that case, you want to try it. And if it works, fine. If it doesn't, then you want it to do something else. If the number you're finding the square root is negative. So you can use it for things like that. There are other errors you can catch using something like this. Okay. So I think we can now start and go to functions. And many of the things we'll be doing, we'll be using more or less functions and modules. So a function is just a code that is pre-written or written to perform a certain task. Let me just say so pre-written. So for instance, if you're using, if you know about Excel, if you do something like this in Excel, sum A1 to A5, it's going to sum the numbers from A1 to A5. We're going to sum the numbers from A1 from column from row A1 to row A5. This is what this will do. So this is equivalent to you doing A1 plus A2 plus all the way to A5. So instead of doing that, somebody has already written some function, and you can just call the function with the argument the person has written, and it does that for you. So it's similar in this case. You can write the function, and other people can write the function. So I'll tell you about two ways to access a function. The first way is the simplest one. So you've seen a function like so. An example of a function is the print function. So it does, what does it do? It prints, and what does it print? It prints whatever is in the parentheses. Okay. So you pass something in the parentheses and it prints it. So this is what a function does. So you pass something in the parentheses, so you can say f of 5, 6, 7, or 5, 6, 9.5. So you pass something in it and then it executes it. In this case, you pass what you want to print in it, and it does exactly what it should do. It prints those values. So print is an example of a function. You'll see later how to write your own functions. Okay. So in this case, I can just do like print, then I pass an argument. So what you pass to it, we call it an argument. Hello world. So so if we run this, it just prints hello world for us. Okay. So this is one way to call a function. Another way is to Another way is to use the dot notation. So I'll explain what I mean by that. So in this case, you pass the argument. Pass the argument to the function call. So that's what you do here. So you make a function call, you pass the argument. Another way is to use it. So the second way is to use the dot notation. If a class was defined, okay. So I'll explain what I mean. There's something called class, which I thought we will be able to get to, but for now we are not able to get to class. I need more than Tuesday for us to get to class and deal with classes. But what that means is this: if you have an object, the object has some functions attached to it. So what do I mean by an object? If you say my string is hello world. Okay. So this string is an object and it has some properties. Okay. You can find the length of my string. Okay. So that's one of the properties. Like I told you, it's stored like a list. The other thing you can do is strings have certain functions attached to them. For instance, you can turn all the string to upper cases. Okay. So you can, how do you do that? You do my string and then you do upper. So if you do this, it will turn my string into an upper case. Let's call this one my string. So it will turn it to uppercase. So what you are doing there is you take the object and use the dot notation to call a function that is attached to this object. Put it this way, is a function that the object has. Okay. So these are two ways. One is you can just call the function just like you do in mathematics. You can just call the function. The other way is to use the dot notation by realizing that many objects, they have a function attached to them, or they have functions attached to them. Okay. So one function is upper. Of course, you can check that there's lower. And then in this case, I can print my string. I can print my string. So I've called two functions that are attached to this string object, and those functions, and these functions don't take in it. I mean, I've not given them any argument. I don't know if they require arguments or not, but I didn't give them arguments. So I run it. Okay. So you can see that this my string upper worked. We converted it to an uppercase.
Yeah.
And then my string lower also worked. We converted it to a lowercase. So I think there's a way you can use to find all the attributes, we call it. No, not attribute, all the functions connected with a particular object. Let me see. This is the way to do it. Yeah, so you can. Okay, so all the functions connected to a particular object, you can just do dir and the name of the object, and then it will tell you all the functions connected to that object. Okay. So for instance, to this string object, there's upper, there's lower somewhere, lower. There's L strip, it strips something on the left. There's R strip, it strips something on the right, and there's so many functions. You can swap the case. You see that there's replace. So you can replace something in it. So let's try to use this replace thing. So let's do my string dot replace, and we'll replace the D with let's replace it with Y. It doesn't mean anything. Oh, yeah. Let's replace D with Y. So I'll call this the new string because it's my string, and then I'll print new string. So what I'm doing here is I'm replacing. Yeah. Sorry. What I'm doing here, my string contains hello world. Okay. Yeah. And then in hello world, I'll replace the D with Y. And then I'll print a new string. Okay. So I print it. So you see, it has changed the D to Y. Okay. If you like, you can replace whole words and things like that. Let's print new string and let's check whether it really replaces the string or just returns another object. So let's see what the original string is. And we run it. Yeah, the original object is still there, so it creates another object for us where D is replaced by Y. how do I know all the properties of this string? I just do dir my string, and it tells me the different functions that I can call using it. Okay. So dir my string. Okay. Now let's go to the interesting thing of you creating your own function. So print was created by some people. Yeah. Yeah, so I think you can do it with dir. Yeah, you can do it with floats also. So let me try this and see what it gives. Yeah, it will give you all the functions that you can use float on. So let's try this. Sonia. And then we will now, okay, so let's write x is 1.0. And then I'll run this. Yeah, so it tells you all the functions that you can use 1.0 with. So you can use this power, you can round it up, you can do this division, you can negate. So these are functions that you can use with floats. Okay. So you can use it. You can use it to tell. You can use dir to tell you all the functions associated with a particular object. Okay. Even if the object is not one of the ones we know, string, float, and integer. Even if it is another object that somebody wrote a class for, or somebody wrote, so you can design your own object. So that's the main thing about main use of class. You can use a class to design your own object. If I go beyond Tuesday, I'll probably show you how to do the thing in classes. So how do you define functions that take list of parameters? So let's say I want to define a function x y, okay, that is x squared plus y squared. How do I do that? Okay. So the basic way you do is you write def function name, any function name, you write the list of parameters, and then you put a colon after that, and then you indent. So you see there's space here, because this thing has to know that this is part of its own function. It's part of the function. You indent it. So Jupyter helps you to indent, but don't forget to indent. So you need to indent. You can use 2 spaces, you can use 4 spaces. I think most people that do Fortran, they use 4 spaces. Sorry, I do Python, they use 4 spaces. So here you put the code. That does what you want it to do. And then at the end, if you want, you can put return. Actually, you should put return because you want it to return something. Okay. If it's not returning anything, you don't have to put return. If it's, for instance, it could be something that's just printing a file. Okay. So in that case, it doesn't return anything, it just prints. Although you may want to return if you successfully printed. Okay. You want to return 0 if you successfully printed, or 1 if you did not manage to print. Okay. So you just define, put the code here, you type return, and then the expression you want to return. Okay. So I'm going to comment this out, and then we're going to take an example of our f of xy, because x squared plus y squared. So this is very straightforward. I can define a new. Sorry, I didn't put a colon at the end. Okay, so you put a colon at the end. Don't forget. I can define a new variable. You don't have to, and then I return z. So you can do this. So the way to use it is you call the function. So let's call it. So let's call it. So I'm going to call my radius, because f, oh sorry, here should not be function name. Okay, let's give the function a name. Let's give it the radius square. So this, I'll call the function, so you can call the function the name. Let's find the radius squared for when the let's give it x as 3.4 or 3.5 and y as 12.7. So I can run this. Oh, actually, so you calculated it. So if you do print my radius 2, I'll run it. You see that it wrote, sorry, I made a mistake, radius. I run it. You see it prints exactly this, and you can check that this is the value of radius squared. So you just write your function this way, and with colon, and then you return the return value. This one you can actually simplify, and I'll redefine the function. If you do Fortran, then you already know that you can do this. Okay. So there's no point for me defining a new variable. I can just return that, and I can just print. Let's print square root of it. So I run it. Okay, so it does the same thing. You use fewer lines of code, but it does the same thing. Okay. I'll give you an exercise now. Write a code, a function to check if a number is prime or not. Yeah, to check if a number is prime or not. So you can write a simple code to check whether the number is prime or not, and then you check whether it's prime or it's not. Okay. So once you write, I'll give you the name of the function. So you check if prime. To check if a number is prime or not. So what I want is I want to be able to just write print check if prime. I want to put a number in there, 179, and then your code should tell me whether the number is prime or not. Could we use z for the same function? Okay, that's a good question. That's in principle, I think you should be able to do that. I've not tried this before. Well, okay, let's check and then see what happens. So someone asked if you could use the same name as the return value. I think you should be able to do that. Let's see. And then I'll just return this. Let's see, I don't know, but let's try. Okay, we run it. Yeah, so it works. Or rather, I think it works. Let's try to. Okay, let's try to do something we know. 3, 4.0. Okay. So better give 5. Yep. Okay. Okay. Yeah. Very. Okay. So you see, inside this function, I've defined x and y, and the usual thing to say is, so here, if I say print x, what's the value of x that will get printed here? Okay. So this x, so yeah. Let's do this. Yeah. So the question is, in here, I do x squared plus y squared. If I print x here, what value of x will I get? The answer is that the x that you defined is only defined within the scope. I mean, within the function. Outside the function, the x is no more defined. It's not this x. So even if you use different x, so let's go here. Let's say x is 3.0, no, 12.0. Okay. And then I've defined the function z of xy is this. I do z is x squared plus y squared. I do all this. So here I print x. Okay. Remember here I'm passing 3.0 and 4.0. Actually, let's do this one. So then that makes sense. So you see here I'm passing 3.0 and 4.0. So when it goes into this function, x will be 3.0, y will be 4.0. But you see here I define x and then I'll print x. Okay. Which x is it going to print? Is it the one that came into this function or is it this one? Okay. So you'll see that this x is only defined within this this is only accessible within this function, and outside the function is a different x from the one that's within the function. Okay. So if you run it, okay, you see it printed the radius, which was 5, and then it printed this x that I set. This value of x that you passed into this is only within this function. It does not go out of the function. Okay. Okay. So here x and y are local variables. Yes. Okay. Is it possible to read table from Excel or notebook to Jupyter? Yes. There's a file. There is some libraries you will use called pandas. You need it for for machine learning, and you can use it to read CSV files, and I think you can use them to write Excel files also. Okay. Because I think I've written Excel files with them before. Okay. Okay. So this x and y here are local variables. Okay. Okay. Actually, this example is not a great example. Actually, the other thing you can do is, because this actually does a masking, the other thing you can do is actually, let's do this and then I'll show you what I want to tell you. If I'm not passing the variable, I can define the variable outside as a global variable if I'm not passing it. So let's do this. So this I'm going to, okay. Let's write this as f, and then I'll return this. Let's write it as w. It's 12. So I define f of xy to be z is x squared plus y squared plus w squared. Or let's see plus, yeah, plus w. Okay. You can look and say that w is not defined in this function, but it's defined globally. So if I do the same thing now, I say yeah, I say print w. Okay, so now we are not going to get 3 plus 4. Sorry, 3 squared plus 4 squared. Sorry, I think I made a mistake. I think. Sorry, please hold on, because this is supposed to go in, and if you return C, but I have to think about this carefully, because if I return, oh sorry, I need to change the function now. Okay, good. So here I call the function. Okay, so it works now. So here I define a function using 2 variables, x, y. Okay. But there's another variable w, which I'm not passing into the function, but I define it outside the function. So when the code comes, it reads w 12.0. So this is a global variable. And that variable affects the f of xy in here. Okay, so it's going to do x squared plus y squared. Where does it get the w from? It gets it from outside the loop because I defined it. So these variables are global, okay, because it defined before this. So the interpreter comes, so you have to be careful. The interpreter comes, it knows that there's a function f of xy. Okay. Before I call the f of xy. So it needs to know that beforehand. Okay. So and then I pass 3 and 4, but w is already defined before the function. So w is already defined here. So w is already defined here. When it comes here, it takes so the interpreter reads this and knows about the function f of xy. Then here, when I call f of 3.0, it takes my 3.0 here, my 4.0 here, it squares this, and it adds w to it, which is 12. Okay. And then it returns this z. When I print this, I don't get 5 again because I've added 12 to it. And then w is still 12 like before, no problem. Okay. Someone will say, can I do something like this? I print this and I do my number is a function of 3.0, and then I define this afterwards. Okay, can I do something like this? Okay, so I call the function before I define it. So let's try. So you see, I get an error. Like G is not defined. Okay. Whereas if you have a code like in Fortran, you probably will not get an error if you define a function anywhere in your system, because in Fortran, it is compiled, it is not interpreted. So in Python, it's interpreted line by line. So it has to have seen the function before. So it has to have seen the function before it knows what to do. Otherwise, when it gets there, even though you define the function after, you see at this point, line 11, it tells me G is not defined. So it tells me already that there's a problem with line 11 because it doesn't know how to do G of 3.0. If you compile the function, compile codes, then for the most part, it doesn't matter where your function is. It's going to find the function and compile it. Okay. Well, in this case, it's interpreted line by line from top to bottom. So it needs to know where it is. You don't have to write your function yourself. You can call a function and then use it later on. Okay. So we will see how to do that later on. Okay. So the way I've done this, I've set W to be 12.0 here. Is a global variable, is outside this def thing, but I'm using it inside. So it behaves like a global variable. Okay. But otherwise, the function you pass are local variables. Another thing that Python allows you to do, which for beginners, when you're reading other people's code, it can be very confusing.
Please, hello?
Yes. Yes.
Please, I didn't get what you explained about the W acting as local variable.
Oh, it's a global because it's outside the loop, but I use it. Sorry, it's outside the function. So you see this W is outside the function, but I use it within the function.
Okay, so where within the function is still a global variable.
Yes, because I defined it outside the function.
Okay. Okay.
So if you print W, it will print this value. Actually, an interesting thing would be to see, let's check. If I change the value of W, does it change? So within the function, I change the value of W and I print W. So I don't know, will it print 12 or will it print 3? This one is going to give me an error, no problem. So let's see. Okay, let me get rid of this so it doesn't give an error. Then I'll see what I have. So remember, you need to define the function before, and the interpreter has to see it before it runs it. Let me see. Let me try here. Sorry. Local variable W reference before. Oh yeah, reference. So okay, so when I try to do this, now it sees W as a local variable. When I run it, it gives an error because now W is referenced before assignment. Oh yeah, because now it sees W as a local variable. This is interesting. I have no clue why it does this. Okay. So I'm trying to understand why, although W is a global variable, when I use W here and W here, why does it complain? Okay. I'll think about it. Why does it complain? But if I don't, just after. Yeah, I know. But what my question is, why doesn't it use this global variable W? Okay. Because it sees the W and it's here, but then inside here it complains that, yeah, I don't know. So because I would have expected that it will use this W as 12, and then inside there, then it doesn't complain. Okay. Okay. So this is one of the things I have to figure out, and if you can figure it out also, that would be great. This one. So we'll see the interesting thing is that in functions, you can use default parameter values. Functions. So the default parameter values, you have to put them at the end. Okay? So I'll define function 2. I'll use x, I'll use y, I'll use r equals 2.0, and I'll use d equals 4.0. So
I have a question concerning the
go ahead.
w.
Yes.
Shouldn't it be defined before the function? I mean, at the first line.
Yeah, inside the function, you mean?
Yeah, it is inside the function, but you define it. I mean, you call it before you define it.
I call, yeah,
You
here
use-
I call it before I define it.
And then you define it. Isn't it the origin of the trouble?
Yeah, but what I was thinking is that because I have w outside, right?
Yeah, I understand that. Okay.
That shouldn't, because if I do this now, this will work because it takes w as 12 and it works. Right?
Yeah.
But if I now put this w as 3.0 inside, then it's a big problem. So I think maybe the variable within masks the variable, the global variable.
Exactly. I think the same because the function see it, so it's a local variable if it is defined in the function, else it's a global variable, right?
Yeah.
Well, what if you define it before using it inside the function?
Yeah, I think if you define it, like if I define it here.
Yes, before z.
Yeah.
Before z.
Yeah, you can do that. You can define it here also.
Let's see how it behaves.
So this is going to work. Yeah. This is going to work.
You may
But
use
the thing I wanted
another,
to do
you may use a different value. Let's see if it can print that value.
yeah. So this is going to work. There's no problem. So I do it and it's going to work. There's no problem with it.
Can you change the value so that you know which one it is printing?
Oh, change the value. Okay, yeah. So
yes.
Let's make this 14. This is 12. Yeah, thanks. Run it. But I'm not sure. Did you run?
It's not seeing it. It's not seeing the top.
Yeah, so it's not. Let's make something simpler for us. Let's just add the numbers and then we'll know. Okay. So 3, I'm passing 3, 4, and adding this. So in this case, you expected it to do 3 plus 4 plus 12. Okay. So, and then I don't square it again. So you expect it to do 3 plus 4 plus 12, 19. So it should give us 19. Okay. So exactly it gives us 19. Okay. But then it means W, which is this W, that's 14.
Yes.
Because this is a local, yeah. But yeah, because this is a local variable. What I was trying to do is, if you comment this out, now it's going to print 3 plus 4 plus 14. But you cannot change the global variable within this place. So if I do this and I run it, sorry. So it's going to give us 3 plus 4 plus 14. Let's see. So 3 plus 4, did I run it? Yeah, let's run it. Yeah. So this is going to give us 3 plus 4 plus 14, which is 21. Okay. But you will not be able to change the global variable inside this function.
Okay.
So this is what I did. No, it sees this one.
Yes.
If you define it again inside, the one inside will mask the one outside.
Okay.
Yeah. So I didn't define it again inside. I just used the one outside, the global variable. But you are not allowed to change the global variable within the function. So this W equals 3 that I'm trying to do will not work.
Okay.
Yeah. Okay. So let's see. So for some function, you can put in default parameters. So the way you do it is you put all the variables for which you don't have default parameters, you put them first, and then after that you can put all the default parameters. Okay, so this is very important. You put the default parameters after, or you put the variables with default parameters after the ones that don't have default parameters. Okay, so X and Y, they don't have the default parameters. I put them first, and then R has a default parameter 2, D has a default parameter 4. Default parameters means if you don't supply those parameters, then it's going to use these default parameters. Okay. And the order is important. Okay. So I can do this. So if I don't, let's just add the numbers. So I'll say Z is X plus Y plus R plus D. So just adding all the numbers. If you don't supply R and D, it's going to take 2 and 4.
Okay.
So let's call the function.
Well done, sir.
So let's call the function. So I'll say print. Let's just call it to the print function. X, I'll put 3. Y, I'll put 4. And then I don't put anything else. Okay. So it's going to take R to be 2, D to be 4, and it's going to do that. So let's do this with D squared. The reason why I'm doing this squared. Okay. So if you run it, it's going to do 3 plus 4 plus 2 plus 4.0 squared. Let's do 5 here. So it's going to do 3 plus 5 plus 2, although I didn't put any 2, then plus 4.0 squared. Okay. So we run it. Oh, sorry, I'm not returning. I need to return something. So I return the value. So I run it. Okay, so printed 26. So that is 3 plus 5 plus 2 plus 4 squared. So that's exactly 26. Okay. If I can change the value of R, and instead of 2, I put 1. Okay, so now it's going to give us 25. So I'll run it again. What am I doing? Okay, so it gives us 25. Because now I put a value for R, so it doesn't use the default value again because I put a value for R. Okay. For D, I didn't put a value, so it's still use the default. Let's put 0. So now it's going to use 0, so it will be 3 plus 5 plus 1, and that's all. And the value I gave to it is going to use here is 0. So I run it. So it just gave us 3 plus 5 plus 1, which is 9. We did not use the default value, it used the value I gave to it. Let's check something. Can I do this and use the default value for R? Okay, so I do 3, 5. For R, I want to use the default value. And for D, I'll use 0. So it tells me it's an invalid syntax. So I think you have to fill up everything, and then only the ones you don't have. Yeah, so I think you have to fill up everything. This one, and then just the ones you are not using is the one that you don't fill up. Okay. Okay. Okay, so there are 2 more things. Okay, okay, let's do this. Let's take a short break for 5 minutes. I go downstairs, I go get some water, and then we'll continue again. So let's just take a short break for 5 minutes. I'm kind of getting tired. Yeah. So we'll resume in exactly 5 minutes time. Okay. Okay, so I think we are back. Is it 5 minutes? No, we have 1 minute left. Let me see the questions. Oh, okay. Okay, so I think we are back. So let's do some things with functions. Okay, so I think in many, so I can do this. Okay, so I need to do something like this. So I have this. Okay, so usually when you have functions in, say, Fortran, well, you usually know how many variables you want to pass. But it turns out that in Python, even if you don't know how many variables you want to pass, you can still write the function to pass an arbitrary number of variables. Okay. So we'll do something like this. Okay. So to do that, of variables to a function. So let's define a function. Let's define add numbers. So okay, what we want to do is we want to define a function that you can give it any number of integers, and it's going to add them. So we want to say something like add numbers, and you can do 5, 7, sorry, 5, 8, 9.5, or 9.6, 9.5, or whatever. You can write anything, okay? And it's going to add all these numbers for you. If somebody else comes and gives more numbers, or less numbers, it's going to do that. Or if somebody comes and gives more numbers, it's going to add all these numbers together.
Sir, please scroll down a bit, sir.
What? Oh, you want me to scroll down a bit? Okay, so
Yes,
I think, yeah. So in this case, I'm using this to add. See, the thing I don't know if I could. What I can't. Okay. So I want to add. I want a function that can add an arbitrary number of variables like this. Okay. So I don't know how many numbers you want me to add, but whatever it is, I want the function to be able to use as many variables as you want. Okay. So the number of variables is not fixed. So how do you do that? So I'll have this called def add numbers. You do that by putting star. For the argument, you put star and some name of a list. Okay. Let's put num for the list. It doesn't have to be num, it could be anything. I could put star or more. Okay. It could be anything. So I'll define it. In this case, I want it to add the numbers, so I put sum is 0. So this or more now, you can think of it as a list. Okay. So because I put star or more, then it's going to take this as a list, and then I can iterate the list. I can say for I in or more. So now the or more is a list, and then I can do sum is sum plus I. If you like, you can print it and everything, and then at the end, I want it to print this sum for me. Okay. So when I call this function will add up all the numbers and it will print them. So I don't have to put a print in the main function. I just call it this way. The function itself, this add numbers, it adds all the numbers and it prints the final result. Okay. Does anybody have a question about this?
Yes.
Yes. So what's the question?
I don't really understand. Yeah, thank you very much, sir. How is going to do the addition? Is it going to add 5 plus 2 plus 7 or 5 plus 8 plus 9.6 plus 9.7? So I don't really understand how the command will do.
Once I do this star or more, then this set of variables, they are put in a list. So this is the same thing I just put in a list here. Okay, so you remember if you want to iterate a list, this is exactly what you do for I in OMO. So let's say I have a list that I call, okay, OMO equals, so I form a list. So remember from yesterday, how do I iterate this list? All I have to do is for A in OMO, I can say print A. So it's going to print, so it's going to take this list and then it's going to put 5 in the variable A and print it. And then it's going to go to the next one, put 8 in the variable 8 and print it, put 9.6 in the variable A and print it. So this is how you iterate a list. So when you do this star or more, then this is a list that contains all these elements. And then the rest, like this, is just similar to what we are doing. So in this case, it's going to loop over every element in OMO and it's going to add it to the sum. So at the end, it's going to have a sum of all the elements.
Thank you, sir.
Okay, so yeah, so first you have to know that if you have a list, you can do something like this. And this A will take different values for each of the elements in the list. Okay. Yesterday also we saw that you can do the same thing for a similar thing for dictionary. Okay. The dictionary, if you put A here, is going to use this as the key. Okay. The key of the dictionary. So if you if I define a dictionary this way, key 1, and then A, and then key 2, and D, and on like that, then you can use a similar syntax to get each element of the dictionary. Yeah. So what we are doing here is, okay. First, let's see what it's doing. This is what you do when you want to add a set of numbers. You can write a loop to add a set of numbers, and this is what you do. You define, you first take the sum is 0, and then for every element in the list, you add to the sum. Okay. So if I do this, it's going to print the sum. So it's going to do it for this line, and then do it for this line. This will give us 5, and then do it for this line. It will calculate the sum and print the sum. Okay. So it's exactly what we said. So here it's added all the numbers, printed the sum. Here's added the numbers 2 and 3, printed the sum. Here it added all these numbers. So if you add all the numbers, there's something 0.2, added all of them and printed the sum. So in this case, you don't know how many arguments you're going to get, but no, don't worry. It's going to put all the parameters in a list, and then you can take each of the parameters and print them. Okay. We can do something simple to check this. Let's say that in any list we give to it, it prints parameter 4. No, parameter, the 4th parameter. So that will be the one with index 3. So let's do a simpler thing. I'll call it my 3 print. Okay. It always prints the index 3 of what you have. So the index 3 of what you have is 9.71 in this case. Okay. So I just say print. So that will be print no, sorry, we wanted to print the 3rd item, so that will be print index 2. Okay, so this is what this function does. Yes, I'll answer everybody just now. Okay, so Let me take the question in the chat. Oh, why there's no need for return? Okay, yeah. There's no need for a return here because I don't need the return value. Okay, that's just it, because I don't need it. I just want it to do what I want it to do. So you can think of it like it can work like a function or it can work like a subroutine in Fortran. So I don't need it to return anything. I just want it to do something, so it doesn't have to return any value to me. Yeah, so that's why I don't have a return. If I want it to return a particular number, then I can return it. Of course, you can add up all the numbers and return what you have added, and then you print it. But in this case, I just let the function do everything. So it's kind of like a Fortran subroutine. Somebody raised his hand. If you have a question, you can ask. Okay, so now I define my 3 print. So this prints the third item in any list that you give to it. So it's going to print exactly the third item. So you will see that on more 2. I run this. Okay. So it prints exactly 9.6. Okay. Let's do my 3 prints. 5, 92. Okay, so we do this, and I'll run this now. So you printed the third item. So you see when you pass a list like this, you pass the argument, it sees it as a list. Okay. So once you do star or more, then everything you pass will be in this list. So if you have so many variables to pass, you can just pass it as star or more, and then, or star anything. It can be star normal, so star something. And then each of these, you know that Python, the function sees it as a list, and you can access each element of the list also. Okay. So you can do this. Okay. So even if you don't know how many elements are in the list that are going to be passed, no problem, you can do this. When I first started to use Python, one of the things that I got that gave me problems was the fact that the number of arguments in the function does not match the number of arguments in the call. Okay, when you call the function, so you say, instead of saying f of xy, the guy will just write f of x and it will work. It's like, no, your function has 2 variables. How come this one has only 1? So, or your function has only 1 variable, 2 variables. How come you call it with only one function, 1 variable, and it works? Or you call it with multiple variables, it still works. So this was one of the things that was not so clear to me. So this is the thing. You can use many variables and hide them, and just because this is a list. Okay. Forget about the curly brackets, but it will take this as a list, and in here you can access each element of this list. Okay. So this is very useful thing to do. Okay. So remember also we already spoke about the case in which you have default values for some functions. So that is also very confusing because in this case where you have default values, you see you can actually in this case also say print func2 2 3. So this other one should print 5 plus, it should print 2 plus 3, 5 plus 2, that is 7 plus 4 squared is 16, 23. Okay, so I do that. So you see it prints 23, but if you look here, there are 4 arguments. Here there are only 2 arguments, and it still works. Okay. Because these other 2 arguments are default. So if you don't pass anything to them, no problem. It's going to use the ones that you passed. So you have to pass at least 2 in this case. This is going to use the default, and this is going to use the default if you don't pass something. If you pass something, then it doesn't do that. So you see, for a beginner in Python, this is confusing, that oh, this function has 4 arguments. This one has only 2, but you can still call this function with this with only 2 arguments, and it works because they have default. This one is even more confusing because in some parts of the code, you will see that there are so many arguments, and in some parts of the code, you see that there are 2 arguments. Some other parts, there are more than 2 arguments. Some other parts, there are many arguments. And then you go to the code itself, the function, you just see this, and then you are confused what is happening. How can you pass many arguments with just this? Okay, so this is the explanation. It sees it as a list, and then you can use each of them as you want. Okay.
Please,
yes.
Omar, when I do the same the same example, I have a problem with I goes for I in Omo.
Okay, which example do you do?
With the list different add numbers.
Okay, okay, I'll give you 2 minutes to share your screen. So.
Hello?
Yes, I said
yes.
I'll give you 2 minutes to share your screen.
Oh, to share my screen, okay. But I think I found the problem. Thank you.
Okay, you found the problem. Great.
Yeah, thank you. It's worked.
Okay.
Thank you very much.
Yeah, because if I share your screen, that there are many eyes, like there are 94 eyes, and everybody will see and tell you what the problem is immediately, just like they tell me.
I think I used 4 with capital letter. Doesn't work with capital letter. I think that's what I changed.
Okay. No, it should work all the time. Okay.
It should work with F capital letter. That's
yeah,
what
it should work all the time. Yeah. Okay.
That didn't work when I used 4 capital letter, F capital letter, then it doesn't work. When I changed it to small letter, it worked. That was a problem.
I can look at the code later on and let you know.
Okay.
Yeah. Okay. So in this case, when you just do star or more, it takes it as a list. Okay. Interestingly, you can do something else that will make it take it as a dictionary. Okay. So in that case, we call it keyworded.
I have a question about dictionary. When I was trying to do the homework, I was doing the dictionary for the country and cities. And when I tried to execute it, and I see that doesn't keep the order. Is that normal?
Yes, yes. Dictionary, it doesn't keep the order because you have the key. You have the key.
Oh, I thought it was a problem, but it doesn't really.
No, it's not. Yeah.
Okay. Thank you.
It doesn't keep the order because you have the key, so it doesn't. You don't care who is 1, who is 2nd. You use the key to access the element. So so it doesn't keep the order. Yeah.
Thank you.
Okay. Yeah. So in this example that we did, you see that this star or more takes it as a list. Okay. So if you like, you can let's use star none. Well, star none. So you can do this. So it will still work. You just use any name. Okay. So this takes it as a list. There's another one actually that takes it as a dictionary. Okay. This example, we say this is an example of non-keyworded variable. Okay. Non-keyworded variable length argument. Okay. So there's no key. Okay. But you can do another one that has a key that works almost like you have a dictionary. So in that case, you define. So this is keyworded variable length argument. So the way you do that is you use a def function, and then you use **, 2 stars, and then you can use any name you want. Usually people will do, and then of course colon, and then you define the function. Usually people will do def function. Okay. I'll show you how to do this. You have variable. Okay, so you have the variables, and then so what I'm showing you now will show that you can use keyworded and non-keyworded. You can use fixed variables. Okay, let's call this fixed variables. You can use non-keyworded, so star args, and you can use keyworded star keyworded args. Okay. So this one is fixed arguments, so I'll call it f or fixed variables, or let's call it fixed arguments, fixed number of arguments. Okay. This is non-keyworded, and this is keyworded. Unfortunately, you have to keep the order. Okay. Oh, in the example we gave, my print 355 hello 93 world. Okay, let's go back one step and look at the example quickly. Yeah, so if you have a question like that, you should ask. So let's look at this function, def my print star num, and then print num2, num index 2. So once you pass this list to it, once you pass these arguments to it, it forms a list. So in that list, this will be argument 0, this will be argument 1, and this will be argument 2. And here we're telling it to print argument with index 2. Okay. So we're telling it to print argument with index 2. So here also, when we say
hello,
then it's going to print exactly just this one. Yeah.
Can we use a word? Can we use a word in place of these numbers on the list? That's
yeah, you can use anything.
Letters.
Like which one? This?
Yeah, can we use a word? Yes, just a word.
Yeah.
Like hello without being a string.
Oh, without being a string. I don't know if this will. No, this one will not work because I'm accessing index 2.
Index.
So you have to have at least three variables there. Yeah. I mean, I can change the code, but you have to have for this particular code, you have to have at least 3 variables. Let's say I change the code and I say you should just print the 0th one. Then it will work whatever you put there. Okay. But in this case, you have to have at least 3 variables. Okay. So we go down. So now, okay. So if you see that if you use star args, this will be a list. Okay. And it's non-keyworded. Lists don't have keywords. But if you use star something, then the argument will be passed as a dictionary. Okay, the argument will be passed as a dictionary. Okay. Okay, so let's take an example of this. The other thing is actually you need to have things in this order. Okay. You have to have the fixed number of arguments, and then you have to have the list, and then you have to have the one that behaves like a dictionary. Okay, you have to do them in this order. Okay, so let's do a simple one first, and then we can do something more complex later. So let's do def function 3. Let's take x. Let's take I call it keyworded args. So because it's keyworded, then I have to know what keyword to Voice was off. Okay. So a couple of things. When you are using keyworded args, you have to. Yeah. Very ouch. When you are using keyworded arguments, you have to maintain this order. Okay. So you have to first use the fixed arguments, and then the ones that are not keyworded, and then the ones that are keyworded. You have to go in that order. So for instance, I can't do something like this, X. I can't do something like this. No, you cannot. So you have to first do the ones that are fixed arguments. Okay. Let's do X and Y. And then the ones that are not keyworded, and then the ones that are keyworded. In this case, I don't have those that are not keyworded. So what I'm going to do is, you have to know what the keywords are before you do it. Okay. So you have to know what the keywords are before you can use this. So let's try to do something that takes in the base. Okay, so let me do this. Okay, so I'm going to do func3. And what I want func3 to do is to so func3, I'm going to pass 3.0, and I'm going to pass 4.0, and I'm going to pass my mass. Oh, okay. Let's put okay. My height. Let's put 1.4, 1.5. Okay. So what I want it to do is it's going to take my mass and my height. And it's going to use my mass and my height. Okay. So this is the way I will call the function. I'll call this one, and then I will put the arguments with the keywords in it this way. Okay. So in the definition of the function, I don't put everything. Okay. Yeah, so in the definition of the function, I don't put everything. And then sorry, let me think of something. Let's do a simple example. So let's define, okay, let's do a simple example, and then we can do a more complex one later. Let's just define print for me. Okay. And it just prints for me the arguments that are right to it. So I'm just going to say print for me. This, my mass is 43, and that. Okay. So it's going to print each of these items for me. Okay. So I'll access it this way. Then I'm going to print okay. Let me think of this thing. So okay. So let's see what this code is doing. So what this code is doing is I'm using keyworded variable argument list. Okay. I'll pass these arguments, this to it and this to it. Okay. And then I use this just like you would do for a list. Okay. This first one is the key, is like the key, and this second is like the argument. Okay. So what I did was I just passed the keyworded argument list to it, and then it's able to print the key and the value, the key and the value. Kind of, okay. So what happens is it takes this as a list, sorry, as a dictionary, and that this is the key, and this is the element that the key refers to. This is the key also, and then this is the element that the key refers to. Okay. And it's able to do that. Oh, keyworded. So keyworded argument just means that you pass the argument, but you put a key for each element, for each argument. So I don't just pass print for me 43 1.5. If I do this, print for me 43 1.5, this is non-keyworded. So this will translate into a list, and in that list there'll be 43 there, there'll be 1.5 there. Okay. Okay. So with this, it will translate to a list, and in the list there'll be 43, and in the list there'll be 1.5. So this will be the 0th argument. This will be the first argument. But when you use keywords like this, then it translates it as a dictionary. So when it translates it as a dictionary, this will be the key, and this will be the this will be the key, and then this will be the what do you call it? The element. Yeah, and then this will be the key, and then this will be the element. Okay. So I'm going to take this and I'm going to try to create another code quickly, which will illustrate that. Let's write this one as show for me. Okay. So in this case, what I want it to do is I want it to print the argument that has the name my mass. Oh, sorry. I'm not sure if I need to put a quote or not. I think I need to put a quote. Let's try it, and then I will try to remember if I need to put a quote or not. Yeah, so I think I need to put a quote.
After print, why do you use these kind of brackets?
Thank you. Because I'm tired. Thank you. Okay. Thank you very much.
You're welcome.
Yeah. Okay. Okay. So I think if I don't have the quotes, it will not work because it's a keyword. Let me see. Yeah, it doesn't. Yeah. So you need to put the quotes. Okay. So when you do this, it takes this as a dictionary. Okay. It takes this as a dictionary, and then the dictionary, this is the key, and this is the element, and then this is the key, and then this is the element. Unfortunately, I think the key has to be a string. So then it does exactly this. So the string, the key has to be a string. Okay. So you can use this together with many other things. Let's quickly do one more thing, and then I'll okay. So I tried to do sine 3.5 and it did not work. Okay. Does anybody know why it cannot calculate sine 3.5 for me?
You have not imported something.
Okay, yeah, but yeah, okay, yeah. So that's the ultimate reason. But yeah, so the thing is, yeah, we need to import. But the thing is, as far as this
pi, it's over pi or
no, it doesn't matter. As far as this function is concerned, this kernel is concerned, it doesn't know what this function sine is. This sin, is this sin or what function is this? It does not know what this function is. It has never seen this function before. So one thing you can do, yes, you can define a function.
Fine.
And you can define it. So I can say z is, I think x minus x plus 3 over 3 factorial plus 6. Okay, plus. So you can define your sine function if you want to, but you don't have to in this case. This is the sine function, so you don't have to in this case. And then return it. The interesting thing is some people already have coded all this for us. So you can just use what they have coded. Okay, so you can just import their modules. So this is import. So you can just import the function that they've created already. What I'll do is I'll take a shortcut and then we'll end for today. I'll ask if you can meet on Tuesday. I'll send you a message and you can indicate whether you can meet on Tuesday or not. So what you can do is you can import all the mathematics modules.
Monday we are not meeting. Until Tuesday.
I think Monday you are meeting with, Monday is 25th. I think you are meeting with Pierre Paul. Okay. I sent you a schedule, yeah, Pierre Paul, because it's going to start you off on machine learning. Okay, so you can do from math import star, so it imports all the modules from math, and one of the modules in math is sine. So I import it, and then I hit return. So now when I say sine 3.5, it knows that, and if I say cos 3.0 cos 1.0, no, cos 0, yeah, then it knows exactly what cosine is. Because there are many functions that are already in this math thing, and we can import it. Okay, so Python comes with a large number of built-in functions. Okay, and these functions, they are saved in files that are called modules. So to use the built-in codes in Python modules, you import them into your program first. Okay. If you are doing Fortran, you link it to your code. In Python, you import it first. Okay. So modules are putting modules. So modules are built.
Just like the way we load modules on clusters.
Yes, exactly. Yeah. So modules are built in function, built-in function codes. Okay, so you can use them. So when I do from math import star, there's a math, there's a set of functions that are in this math module, and those set of functions you can, so there's a set of functions that are in this math module. Think of it as is a long list. Okay, so think of this, that what am I doing here? Think of it that when I do from math import star, it adds to my code a function, there's another function, exponential of x, that is defined somewhere. So it's defined in some way and
I can't hear you anymore. It's noisy.
Okay, sorry. So when you say from math import star, it takes this file from math, and that file from math will contain the definition of many functions. So it contains the definition of sine, of cosine, of exponential, of square root, and of different things like that. So there's so there are many functions that are in this math module. So the math module, you can just think of it as a big Python file that contains many functions. So when you say from math import star, you put all those functions above. I mean, you put all those, it replaces this from math import star. It replaces it with all the functions that you need. Okay.
Hello.
Yes.
Can we have access to all the functions in that math through maybe DRR?
Yes, so I think there's a way. I don't know if I've done it before. I think I've done it before. So I think if you do, I don't know if you do DRR math. Let's try. Or maybe you do DRR. I don't remember, but there's a way to know. Does anybody know how to do this? Maybe it's not DRR. Maybe. I don't think it's DRR. I think it's something to list all the functions in the module. I used to think DRR would do it, but I'm not sure. Let me see if somebody in the comments is telling me. Okay, someone said you can use help math. I've not done it before. I've not used help math before. So let's try help math. No. So I think what I would have done would be try this. Sorry. Okay, so what I want to do is print here R math. I don't know why it said the main math is not defined. Okay. Okay, so these functions are there. I think it came because I imported everything. but I don't know how to do it if you don't import everything. Okay. So I just did dir. Oh, okay. So I think what you can do is I can import math. Let's import it as empty. Okay. Or let's just import math. Then I'll print dir math, and then let's see what happens. Yeah. So this is interesting. I won't go into the details about it, but what I did was I imported math and then I print. So dir math. You could, with Jupyter, you can just write it without printing. If you just type it, it's going to print it. So what I did here is, this is kind of different. From math, I already imported all the libraries. Okay. So I imported all the libraries. So if I just do print dir in brackets, it will print all the libraries that are available. So you can do two things. In this case, I wrote import math and I put dir math. I'm not importing all the libraries. Sorry, I'm not. Yeah. In this case, I import. I don't know what to say. I import math, and then I can access each library that is in math. I can show you how to do that later on. In the first case, what I did was to import everything directly. And when you import everything directly, everything becomes available to you. So from here, I say from math import start, everything becomes available to me. I can do sign and anything like that. In this other case, when I said import math, okay, it imports the math, but if I want to access sign, I have to do like math plus sign of 3.5. Okay. Then it prints. Okay. But if you import everything within it, so if you do from math import star, you import everything within it, then you don't have to do, actually, if you do math plus sign, it probably will tell you that it doesn't know what you're saying. Let's see. Oh, yeah, it works. I think it works because I already set. Okay.
Sorry.
Yeah.
Hello,
So
sir.
let me end this by saying this. If you just say from import math, then if you want to access a function in math, you have to do math dot the function, say exponential. You have to do that. Okay? And you can also print the everything that math has. You can print it this way, and it's going to show you a list of everything that math has. Okay? Another thing you can do is you can import everything within math. If you do that, then you don't have to do math dot sign or 3.4. You don't have to do this. In this case, you can just type the sign directly. It's something about the scope, and you can just do this directly. And in this case, also, you can just do print. And yeah, everything has been imported, so you can just do this, and it shows you everything. Okay, so I think we need to stop today. Yeah, and yes, okay, I'll try to send it today. Okay, let me stop. Let me stop it, honey.